Hello everyone. In this video we are going to be considering multiplication of complex numbers. This is a continuation of a series of problems we've been working on complex numbers. To see one of them, just click on the link at the top right corner of the screen. The process it takes to remove brackets in algebraic expressions is the same one we need to multiply complex numbers. For example, if we have x plus 2 in brackets and perhaps x plus 3, we would see that to remove this bracket, which of course is the same as expansion, the first item here is going to multiply every item in the second bracket. So we're going to have x times x plus 3. Then we'll pick the second item here. It's also going to multiply everything in the second bracket. That's a positive 2, x plus 3. So this is the same process that we are going to take in multiplying complex numbers. And a quick recap, we know that the complex number z contains the real parts and the imaginary parts. Thus, if z is a complex number, it's always going to be written as x plus iy, where x is the real part and y is the imaginary part. So let's take the first example. Here are the problems. Find z1, z2 if z1 equals 1 plus j2 and z2 equals 3 minus 3j, and the second one, z1 equals negative 5 plus j, z2 equals j7. Basically, like I said in one of our videos, the imaginary parts can be represented by either I or j. So both of them mean the same thing. Some authors use j, while some use I. Okay, so the first one, we want to multiply the two complex numbers. Now z1 is equal to 1 plus j2, z2 equals 3 minus j3. So z1, z2, I'm just going to introduce parentheses, that's z1, and 3 minus j3, that's z2. Thus, the first item here, the real part is going to multiply everything in the other bracket. So this is 1 times 3 minus j3. Then the second item here, the imaginary parts of z1, that's positive j2, and that's going to multiply every item in the second parenthesis. So this is 3 minus j3. So removing the brackets, 1 times 3 is 3, 1 times minus j3 is minus j3, then plus j2 times 3, that's plus j6, then plus times minus is minus, j times j is j squared, 2 times 3 is 6. So we've got 3. Now these are like terms. Now we would see here that we've got the square of j. And of course, we know what j is. We know that j is the square root of negative 1. Squaring both sides, here on the left, we're going to pull a squared here, and on the right. So the left is going to be j squared. The square is going to cancel the square root on the right. So we can see that j squared is negative 1. Thus, I've got a negative here. Now j squared, this is a negative 1, then 6. So this is 3 plus j3. Now negative 1 times 6 is negative 6. We've got a minus here, that makes it positive. So we can see that we've got two real numbers, 3 and 6. Adding them will give 9. So this is 9 plus j3. So clearly we can see that the product z1, z2 is equal to 9 plus j3. The second one, we've got z1 equals negative 5 plus j, and z2 equals j7. And of course, we can write this as 0 plus j7 because j7 is just the imaginary part. What that tells us is that the real part is 0. So z1, z2, which is the product of z1 and z2, I'm just going to put z1 in parentheses, negative 5 plus j, and z2 in parentheses, that's 0 plus j7. And as usual, the first item here, negative 5, is going to multiply every item in the second parenthesis. Then the second item, the imaginary part in Z1, that's a plus j, is also going to multiply every item in the parenthesis. That's 0 plus j7. So this is negative 5 times 0 is 0. So we've got negative 5 times plus j7. Negative positive is negative. So I've got j. 5 times 7 is 35. Then plus j times 0, 0. Then plus j times j is j squared. This is 1j basically, so this is just 7. Thus, I have 0 minus j35 plus 0 is just minus j35. Plus j squared is a negative 1, so I've got a negative 1 here. Then 7, so this is negative j35. Plus times minus 1 is minus 1, times 7 is minus 7. Thus, I can see that the product z1, z2 is minus j35 minus 7, and I can write this as minus 7 minus j35. Right here we would see that negative is common, so we can have a negative here. This is 7, this is 35. I can also factor out the 7. So negative 7 factored out from negative 7, that's 1. Negative negative is positive, so I've got j. Factoring 7 from 35, I'm left with 5. Therefore, z1, z2 is negative 7 brackets 1 plus j5. And having done this, we would see that we can also factor something out here. Since 3 is common, so I can factor out the 3. So I'm going to be left with 3 plus j. Let's take the final example. If 2 plus j times 3 minus j2 equals x plus jy, find the values of x and y. So basically what this question is saying is that the product of these two complex numbers is equal to a single complex number. So we are just asked to obtain the values of the real and the imaginary part of the product. So solving this, we are going to remove the brackets here. So this is 2 plus j, 3 minus j2, removing the brackets. So this is the first item. 2 is going to multiply every item in the other parentheses. Then the second item here, plus j, would also multiply 3 minus j2. Removing the bracket, we would have 2 times 3, 6, minus 2 times j2 is j4, then plus j times 3, that's plus j3, plus times minus is minus, j times j, j squared, then this is 2. So this is j, these are like terms, negative j4 plus j3, that's a negative 1j, that's negative j. Then minus, j squared is a negative 1, so I have 2 here. So this is 6 minus j, minus 1 times 2 is minus 2, times this minus, that's a positive 2. And this is going to be 6 plus 2, that's 8, then minus j. So thus, we can see that the product here is 8 minus j, which of course is equal to x plus jy. So I'm just going to write equal to x plus jy. So if I compare the real and the imaginary part, on the left side, 8 is the real part, and on the right, x is the real part. And if two complex numbers are equal, the implication is that the real parts are equal to each other and the imaginary parts are also equal to each other. Thus, we can tell that x is going to be equal to 8. Comparing the imaginary part, on the left, the imaginary part is negative j, so and that's the same as negative 1j. So we would have a negative 1. And on the right, we've got a y, so this is equal to, so we can see that y is equal to minus 1. So the values of x and y are x equal to 8, y equal to negative 1. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.